Hi, welcome to my YouTube channel on designing and building ML systems. My name is Manoranjan Pradhan. In this week, we will discuss about data labeling challenges and one of the widely used approach to deal with this challenge called active learning. Majority of the problems that we will deal with in industry are supervised learning problems. And the models that you will build, the performance of those models will depend on the volume and the quality of the label data set. In specific scenarios, these labels are either automatically generated or captured by the system or the business processes. For example, ad click prediction. When you show an ad to a user and the user either clicks or does not click on the ad, the dot gets captured. Delivery time estimation. The time taken to deliver a product or a service is also captured by the system. But there are specific scenarios like churn prediction. The customer will not indicate whether he or she has churned or not churned. Rather, we have to observe the customer behavior for a specified duration of time, and if the customer has not bought any product or availed any services, then we can mark the customer as churned or not churned. But in all cases, like ad click predictions or delivery time estimation, where the labels are generated explicitly, that's why they are called explicit labels, or in churn prediction, where the labels are generated implicitly, also known as implicit labels. These labels are either generated by the system or captured or created and made available as a training set to build a model. But there are scenarios where these labels are not automatically created or generated, but they have to be manually labeled. So there are techniques like hand labels or programmatic labels. And especially you will encounter this situation either in natural language processing or computer vision kind of problems. Let's take a specific case of customer complaints categorization. Let's say there's a food delivery service which wants to go through the complaints or the feedback given by the users, then automatically categorize them and route to the departments or person handling those specific complaints and address them as soon as possible. So this is a classic example of machine learning problem. You can build a model to automatically categorize and route them, and hence the lead time to respond to the customer complaints reduces, which hopefully increases customer satisfaction. And let's say there are three different categories: food quality related complaints, delivery related complaints, and hygiene related complaints. Now, to build a machine learning model, we need to first take the past reviews or complaints made by the customers and manually label them and create a label training set. So now what choices we have to do that? One option to create labels manually is to hire your own labelers or annotators. In that case, it would train the annotators to improve the quality of the annotations of the labels, create a guideline for labeling so that there is a consistency in labeling, and a mechanism to deal with label ambiguity. There could be examples with ambiguity, so you can have a multiple labelers labeling that and take a majority voting or opinion, or you can also have an expert labeler to annotate and label those examples. The other option is to use crowdsourcing or outsource to the third party providers who have built expertise in creating labels. In that case, there could be the concerns of data privacy because you have to give the data to a third party or outside of your organization. In both the cases, the labels are created manually So hence, there is a time and effort involved. But are there any techniques which can reduce the time and effort required to create labels? There are a couple of techniques which are evolving. One is called active learning, and the other technique is called weak supervision. In this week's video, we will discuss about active learning. Let's say we have 1000 examples of past customer reviews or feedbacks, and these are unlabeled. We don't know which review belongs to food quality or belongs to service related complaint or hygiene related complaint. So rather than labeling all of them, we will take a small subset of examples randomly selected, let's say 100 examples, and then we'll ask our human labelers to go through each one of them and label them. Let's say they say, okay, this complaint or feedback belongs to hygiene related problem. This belongs to food quality, and so on and so forth. Now this subset of the data which is labeled becomes our first training set. Let's call it DS0. So we don't completely avoid human labelers here, but we utilize their efforts judiciously. So this is also called human in the loop learning. So once the first subset of training is created, now we'll go and build a model on top of it. Let's say we create a first model, model V0, from this initial set up for training. And once the model has been built, we will leverage the model to predict the labels for the remaining unlabeled examples. So in our case, 900 examples are still unlabeled. Only the first 100 examples which are randomly selected from the complete set which is labeled. And once we predict the labels for each one of them, the model would have predicted the probability that the example belongs to which of the categories. So we will go through the predicted probabilities of the model and find out the uncertainty in prediction in those examples. Now, what is uncertainty? If you look at this set of examples which were unlabeled but predicted by the first model. Let's say this is the first example for which the model predicted that it belongs to food quality or delivery or hygiene related complaint, the different probability values. Now if you look at the probability values, and let's say this example, the predicted probability for hygiene category is 0.90, whereas for food quality and delivery are very small probabilities. So in this case, we can assume that the model is very certain that this particular example belongs to hygiene related. But whereas this particular example, the first one, the probabilities are very similar. So the model is probably not very certain which complaint category it belongs to. So here the uncertainty in prediction is much higher compared to this example. Now how do we measure? So we can use a matrix like entropy calculation, the prediction entropy or categorical cross entropy to measure the certainty or in the predictions. And once we measure the uncertainty in the predictions, we can take the examples where the uncertainty is very high or the entropy is very high. Why is that? Because in the first initial subset that we have selected and labeled as a training set, there aren't much information about these examples. So these are probably newer examples or difficult examples or valuable examples from which we can learn in the second iteration. Now we will take those examples where the uncertainty in predictions are very high, a small set of it, let's say 50 more examples. We'll sort them by entropy and we'll take the examples where the entropies are very high, and then we'll ask the human labelers to go through them and label them manually. So they'll again go through and say, okay, this belongs to the food category, food quality complaint, and this belongs to hygiene related, and so on and so forth. And then we will add these newly labeled examples by the human labeler to our initial subset, and we'll create a new subset of training called DS1. We had initial 100 examples. Now we added few more to our training set, let's say 50 more examples. So now totally 150 in the DS1 training set. Now we'll take that and then create a new model called V1. And then leverage that model to predict the labels for the remaining unlabeled examples, let's say 850 of them. And then again we'll calculate uncertainty of these predictions or entropy, and then find out where the uncertainty in prediction is very high. So this goes in iterations. These are the steps in active learning. So manually labeling examples using human labelers, we'll create a first data set DS01, and from that we will build a model V0. The model is trained from these examples V0, and we will also look at the model accuracy, maybe through cross validation, and then we'll use the model to predict the unlabeled examples, and then select examples with a high level uncertainty in predictions, and again manually label them. In the second iteration, we'll create a second model, then third model, and so on and so forth. And in the meantime, we'll keep checking the model accuracy. And if we have achieved the desired accuracy, we'll stop the iteration, and that becomes our training set. So if you approach this, rather than labeling all 1000 examples, maybe 300 or 400 examples would be sufficient to reach our desired level of accuracy. So to recap active learning, the first assumption is, of course, all examples are not equally valuable for learning. So we have to find a mechanism to find out the valuable examples. So use a matrix to pick examples that seems to be most valuable. So in this case, we used entropy. The human annotators only label the valuable examples. This is also called query learning, because we query which examples we should learn from in the next iteration. This of course improves efficiency for creating labels for model training. To carry out the steps of active learning, you can use a framework called Model, Modular Active Learning Framework for Python 3. It supports two techniques, uncertainty sampling and query by committee. Uncertainty sampling is the one that we discussed, where you sample valuable examples based on uncertainty or entropy. There is also another technique called query by committee, where you build multiple models on the initial set of labeled examples and then predict the labels of the remaining unlabeled examples by multiple models. And then you choose examples where there is a disagreement by the models, or the disagreement is more, and then label them manually and use them in the next iteration. This brings us to the end of this week's video. where we learnt about active learning. So thank you for watching, and I will see you in the next video with a new topic. Thank you again.